Hi guys, today is a product review day. We got a wonderful clamp meter from Kaiweets. They sponsor the video and they sponsor the product too. Let's check out how good is it and how good will be for our business too. We have the manual and I recommend you to read it. It's very important about it. We got a beautiful case, the clamp meter, test leads and a thermocouple. Batteries might come in two, or depending from your country, they can be removed in the customs. I already placed mine. The test leads feels nice, okay, it's flexible, it's rated for 10 amperes and also category 3 for 600 volts. The standard thermocouple comes with banana connectors. And now, let's know about this puppy. This unit, as example, has 600 amperes scale, 60 amperes scale, and volts, all of them in AC DC, with the low passive filter. Has hertz measurements, frequency meter, and duty cycle too. Like any multimeter, compact here, diode test, capacitor test, continuity and ohms. Temperature for degrees Celsius, Fahrenheit, and this is important guys, something incredible too, low impedance multimeter. For many of us, we have to go to the needle multimeter, the wire one, because we need low impedance multimeter when we need to eliminate the phantom readings on the display and to load the circuit a little bit to see what is going on. And this toy, it has it. Something important, I wish many multimeters to have it, it can zero the value before to start making the measurement and function selection. Also, it can display the maximum or minimum or eliminate that and just the average. And this is important to mention, this multimeter makes 3 readings per second. Has the display light. Of course, I have to turn it on. And also working light for when you are doing something in the electrical panels. Everything rated for category 3, 600 volts. Also, we have the non-contact voltage, and it detects voltage field and help us to identify where wires are passing by or if the wire has the main line, the hot one. We have to press it in any function we select. Just press it and hold it and we get the no contact voltage. I'm going to apply 1 ampere DC across the clamp. That's a very low current for a clamp because clamps require a lot of inductance, a higher electromagnetic field. Anyhow, I cannot make the 600 ampere test, but believe me guys, to make the 1 ampere test is a tough test when we require a high electromagnetic field. So let's see what can we do. We are in the 60 amperes scale. We make sure it is DC and we hold the button to 0. Now we 0 it. And just apply the current and let's see. Here about 1 ampere, probably 4 milliamperes. We know the analog to digital conversion has difference between the steps, same here, but anyhow we are very close to the ampere. So let's say it's great. We got here 0.96, almost the one we need. It passed the test. Let's start with the 10 volts reference. Ten volts. Now some resistance. The first one is plus minus 5% and the last one too. The rest of them, they are plus minus 1%. Let's check it out. One ohm, 10 ohms, 100 ohms, 1 kilo ohm, 10 kilo ohms, 100 kilo ohms, 1 mega, and 10 mega ohms. This is great, guys. What about capacitors? Let's check. One nanofarad, 10 nanofarad, 100, 1 micro, 10 micro, 100 microfarads. Excellent. Let's try diodes. This is a normal silicon diode, a faster diode, red one, amber or yellow, green is, let me turn off the lights. Maybe there is a better view with the camera. Can you see the green to light? The blue one and the white. Yes, there is white. Continuity Did you see? 31 doesn't make any noise. 29 point something, it makes the noise. Something probably we watched in other videos and catch my attention to is if I set the non-contact voltage button, and I watched in other videos that the unit is giving false reading because there is not any cable here with voltage, but it's showing the alarm. So I wanted to make a test to see if the units are defective or not. And I found the following thing. This is an electromagnetic field reader, and if I put it in the same position it's showing me there is a harmful magnetic field. So it's not that this guy was giving a false alarm. It's truly telling me there is a magnetic field here in this point. And now I'm going to change the view. This is what we expect it's going to do. It will not make any noise until I get close to the cable, right? That's all. That's correct. But the point is, it was not effective. In one electronics laboratory like this one, I have so much electromagnetic interference, electromagnetic field coming out and being reflexed too, because this equipment is grounded, but the stand is not grounded. And it's like a mirror that projects the signal like one jaggy antenna. As example, the jaggy antenna, I have the elements, and just by adding without any contact one piece of metal behind, it works like a mirror with a light. So it happens to other YouTubers and happens to me too, not because the device is defective. It's telling me there is a harmful voltage field around this area. So it was making me a favor, telling me there is danger around. And we thought it was defective. No, it's not defective. Works fine, but if I'm going close to the lamps, the fluorescent lamps, as example, because we have a lot of lamps in the studio when we are recording, or if I get close to the equipment, it will make noises too. So the product is good, and what you watch it in other videos, and I make the experiment here myself, there is not fake reading, there is not false alarm. This is a polluted environment. But why the multimeter is not so sensitive like this unit? The reason is because this sensor is just a piece of metal and it works like an antenna, and this too. But the jaws are a metal core, iron one, and it reflects what the piece of metal, the antenna, gets. It reflects exactly like the light when we put a mirror next to it, and that amplifies the signal like the jaggy antenna that only requires one piece of metal behind to reflect the signal like the mirror with the light. That's the reason why it's more sensitive and there is not any defect. It's able to pick up a better electromagnetic field and let us to know there is radiation around. The unit is perfect. Who warns you doesn't betray you. The unit is doing an excellent job telling you there is radiation. For the next test, I'm going to use a function generator with a sine wave, 1 kHz, 1 volt RMS at the output. And the frequency meter says 1 kHz, 999.9. The oscilloscope is giving a reading alike, 1 volt RMS, and also the duty cycle is about 50 point something% relative to the center. This is our wave, and this is our device under test. Now let's try the duty cycle. 50%, 50.1, not too far away from what we have there. And let's try the true RMS voltage. Let's remember we are in 1 kHz. It's in DC, AC, and look at that. 1.005 volts. That's great. Let's pay attention to the following signal. I have 1 kHz frequency, 1 volt RMS. Pay attention to that, 1 volt RMS. But I am shifting the frequency, the sine wave, between a sine wave, making a chaos that starts in the 60 Hz and ends in the 1.8 kHz, like an electrical drill in 1.8 thousand revolutions per second. So this modulation gives me all this chaos. And I need a microcontroller intelligent enough, and I need filters to be able to, between this chaos, take away the modulation and show me the 1 volt RMS. And that's what Kaiweets is doing with this kind of filter. Pay attention to the screen. 1 volt RMS as it is there. This is our output. And our connection and our device under test. And we compare it to with a higher gamma multimeter. And we got a reading very alike. So Kaiweets was again accomplished with the specifications. As we watch it, there is already a very good low-pass filter in the device. But also there is a button and a display for AC specific low-pass filter. And this is when we get frequencies that can affect the measurement. And let's analyze what I did here and how did I get this 1.7 volts AC on the screen. I'm combining in the output two waves. 50 Hz, 5 volts, peak to peak, and in the other channel, 50 kilohertz and half volt up, half volt down. So when I mix those signals, I get this result. This is our 50 Hz wave, and mixed in it like a kind of noise is the 50 kilohertz. And if you are in a computer, not in a smartphone, you can appreciate the voltage RMS as 1.75, 1.76. So I got exactly the same measurement on the Kaiweets multimeter or clamp meter. So about the AC with truly low pass filter, yes, it's doing the job. Now let's check this value. This is the wave, almost the same as we watched it in the oscilloscope. Yes, right. The 50 Hz and the 50 kilohertz parasite on it. So we have 5 volts peak to peak, 50 Hz, and this is a distortion, I will call it in that way, of 20%. That means plus 50 millivolts up, minus 50 millivolts down in 50 kilohertz. The low pass filter, as we watch it in that button, is no more than some low frequency after that point, a killer. So this is the wave that was parasite on it, and now rest in peace because the killer didn't let that frequency to go to the measurement. So as the result, we got only the 50 Hz wave, and this is the formula. Voltage RMS is equal to 5 volts peak to peak divided by 2 square root of 2. That is 1.76. What we watched on the oscilloscope and what we watched on the meter. We can take a look to other multimeter to see if it was alike. There is here a cable and it's not connected to anything. And can you imagine, guys, it's already giving a measurement of 28 millivolts. Just imagine a long distance wire cable from one electrical panel next to the high current, high inductance cables flowing the current. That current will be transferred to a cable like this, and it will show several volts, and we are not sure if the cable is connected, yes or not. And the way to get the right measurement is to use a low impedance multimeter. And we passed from the 27 millivolts radio frequency that the cable is picking up to 0. The phantom reading is not there anymore. Low impedance. In few words, an amp meter made for electronics with well done low pass filters. Its screen changes the color after 80 volts AC or 3 amperes, and it does it in order to tell you there is danger and you are dealing with high dangerous voltage or current already. 10 MHz frequency counter, 6000 counts display that made it very useful for repairing in power supplies in the range of the 3 volts, 3.7 to 5.5 volts. Whoever is dealing with the smartphones, tablets, and any kind of device with the new batteries knows what I'm talking about. And the best is DC Clamp Meter with 60 amperes scale for electronics workbench or automotive repairing. Kaiweets HT206D passed my test in this product review and I will recommend it. Thanks guys by watching the video. Thanks Kaiweets for giving us the opportunity to make a product review about this device, and everybody is welcome for the next video with more about electronics and more product reviews too. See you next time. Don't forget to subscribe, give a like if it was worth it to you, and share it.